In this video, we'll be going over a binary tree in-order traversal. So given the roots of a binary tree, return the in-order traversal of its node values. So in our first example, we have 1, 2, 3. In in-order traversal, we have to visit the left subtree first before we visit the roots, and then we visit the right subtree. So if we're currently at this node, we got to visit the left subtree first, which is nothing. So we just visit the root node, which you get 1. So you get 1. And then we move toward our right subtree. But before we visit 2, we have to visit the left subtree first, which is 3. And then we visit the root node, which is 2. So we get 1, 3, 2. Let's go over the dot process. So we will be implementing the recursive in-order traversal. The direction of in-order traversal is left, and then roots, and then right. Let's go over the pseudocode. So we're going to create a list of results to keep track of all node values. Then we're going to implement the recursive traversal, or recursive in-order traversal. And then what parameters do we need? We'll first need our node, our current location inside the input tree, and also the resulting list of all node values. And then what's the base case? If the current node is null, then this means there are no values here, so we can return from the recursive call. Then in each of the recursive call, we will first need to traverse to the left subtree. So we're going to say recursively traverse to left subtree. Then we want to process the current node, which means adding the current node value to the resulting list. Then we can recursive traverse to the right subtree. Let's go over it before this, and then after we process all of the nodes, we can return results. Now let's go over to time and space complexity. For the time complexity of n, where n is the number of nodes in the input tree, we visit each node once. And then our space complexity is O of h plus O of n. So let's go to O of n, where n is the number of nodes and h is the height of the input tree. Just the recursive call stack memory, and we also get our result list. Let's go over the code. So we're going to create our list first, the results, to keep track of all node values, and then we can return result after. And then we're going to perform our recursive in-order traversal. Keeping track of our current location and also a list of all node values. If node is equal to null, then we can return from the recursive call. We first want to traverse to our left subtree first, so node.left. And then we want to process the current node by adding the current node to our resulting list, and then we want to traverse to the right. Let me know if any questions in the comment section below.